Hello everybody! Today in MacGyver's engineering I want to show you my newest invention or adaptation, or I don't know how to call it. Um, as you can see, we are in it's my workshop, this is my desk. I know how it looks. This is most of the time. I can't do nothing about that, this is a permanent condition. I gave up. So what from this mess is my newest project is this tin. So what is it? Any guess? Any guesses? Yeah, of course. This is a tin after how you call it, a polish for metal. I give you a hint. Here is a vent, um, which is old fan from a PC, from a processor, and it blows on the elements that are below it. I'm making this video just before I'm gonna put that thing together, so that's why I want to show it right now. Here inside of it there is windings of how you call it, this is resistant wire. So this what basically this is going to represent is going to be a heat air gun. So this is the two elements, main elements of it. Now I am in the process of adding a handle to it. So this is the ready product. It looks hilarious, I would say, but that's not the point how it looks. Well, maybe I will put some background so you actually see it, what it's made of. Yeah. Okay, so let's just point out some major parts of which this is made of. So this, inside there is a winding of a resistive wire, and this is basically a tin after a polish for metal. Never mind, it's a basically piece of metal tin. This is piece of aluminium. I had to shape it up so it would accommodate this fan. And this part over here, it's actually from a baby cart. I don't know if it's a, I know there is a proper English name for this baby, the thing that you put your baby into, and sometimes they have them with umbrellas. So this one was with umbrella. But of course it was a piece of junk, so everybody, somebody just throw it away. But this is quite a useful thing if you think about that. So the fan that I used before didn't really work for me because of some current and voltage problems. This one has exactly the same voltage, but it works on a different current, which allowed me to omit additional problems with special circuitry to charge this 12-volt fan with. I will have to use some power supply extra for it. And this one was actually capable of working without um, using basically one large capacitor, in line with this fan, cutting off everything from 230 volts of mains down to 12, about the 12. I just add extra capacitor, resistor, and so on, and it works. It's fine. It's perfect. And over here we have this how you call it, this is a voltage regulator or speed regulator from a garden hoover. This one is from a drill. This one was from a drill, and well, you can use this one if you know how to wire it up. It's pretty simple. If you don't know how to connect it, when you disassemble this, you know, check which one is phase and which one is ground and so on. Rated for a proper power according to my coil, to my resisting wire inside, so it will handle it pretty nicely. And extra switch to switch off the heating completely. So now time for a little demonstration. So how it works. Basically, first of all, starts, the fan is running right away. Right now there is a cold air, nothing special. Now this is the regulation, has I guess 6 or 8 degrees of regulation steps, but you know, who cares about that, doesn't matter. Over here I have a old PC board, and today we will take this big one over here. It's a MOSFET. What we are starting off is, first of all, we have to set it for 0 because we are going to preheat it, and I think until number 3 the temperature is very low, so well, maybe not very low, but low, just to preheat it. And I already cannot push my fingers under it and hold them long enough. Let's put some more light over there. So it's better to heat up both sides of the circuit board, because we don't want to overheat it on the one side and have that impression that it was done well, while in fact we will burn the chip that would have to transport all that heat down. So it's getting hotter and hotter. Maybe I'll give even about 5. This part doesn't really, I mean the upper part doesn't really heat up very much. Ouch. It's hot. It's hot. So if it's hot, I think the temperature is not hot enough to melt this solder over here. Now we'll flip it over, and I will put it 2 degrees higher, and I think this should be just enough to make this chip want to come off. Still sitting. Actually, it's not a chip, it's it's a FET, so it's not a chip. It would be nice to have a better nozzle, but if you have a smaller nozzle, you need actually not a pump but a compressed air. I mean, not a fan but a compressed air, and I don't have a pump. Oh yeah, and that's it. As you can see, it went out pretty nicely. That's a little bit how you do it. And by the way, the final procedure is to go down to 0 and switch off the heater completely, so the blower will cool up the entire device. So we will not have any issues later on. By the way, cables are in a silicone, I think it's called silicone insulation, which is heat resistant. All this red thing is 450 grades centigrades rated, so it will not get on fire. You know, if you don't know what to use to build that stuff, don't touch it. You know, this is MacGyver style, but remember, MacGyver never was an idiot. He won every time. Not like me, but never you know, you cannot beat the master. More videos coming soon.